Imagine standing on a remote beach at night, gazing up into the vast, unending cosmos. The stars twinkle like diamonds, but amidst their serene beauty lies the astonishing truth: there are points of light thousands, even millions, of times brighter than anything you can see with the naked eye. Among these celestial beacons, quasars stand out as profound enigmas, inhumanly brilliant objects at the edge of the observable universe. But what exactly are quasars? Why do they shine so brightly? You're about to embark on a thrilling journey through space and time to uncover the mysteries surrounding these celestial titans. If you stick with me, you're not only going to learn why quasars are the brightest objects in the universe, but you'll also discover the remarkable revelations that could change how you view the cosmos. So, buckle up. What do you think a quasar looks like? At first, you'd think it's just a speck of light, but when you realize it can outshine entire galaxies, it becomes a dazzling point of intrigue. Quasars, short for quasi-stellar objects, were first identified as some of the most distant and brightest sources of light in the universe. When astronomers first observed them in the 1960s, they were baffled. These celestial entities were emitting incredible amounts of energy, much more than an ordinary star could generate. In fact, a single quasar can emit more luminosity than 1,000 trillion suns. Yes, you heard that right, 1,000 trillion suns. Now, imagine the implications of that fact: an astronomical powerhouse that can outshine entire galaxies. But what fuels these cosmic light bulbs? This is where the mystery deepens. To understand what a quasar is, we have to talk about black holes. Picture this: at the heart of every quasar is a supermassive black hole, a giant that weighs millions, if not billions, of times the mass of our Sun. But don't think of them as merely destructive forces; they're also incredible engines of energy. When matter spirals into these black holes, it forms an accretion disk, where it's superheated to mind-boggling temperatures, generating copious amounts of radiation across the electromagnetic spectrum. This nuclear furnace causes the surrounding area to illuminate with incredible brightness, which is then what we observe from Earth as a quasar. Are you starting to see the connection? A single quasar is not just a flash in the cosmic pan, it's an entire energetic factory powered by greed, a cosmic entity voraciously consuming matter, spewing purity and power across the universe. And here's something to think about: how far do you think we're able to see these quasars? Some of them are billions of light years away. By peering into them, we're effectively looking back in time, witnessing the universe as it was in its infancy. Imagine being able to watch the dawn of the cosmos unfold right before your eyes. Quasars existed when the universe was only a fraction of its current age, typically around the redshift of 6 to 7, meaning they formed during a time when galaxies were just beginning to coalesce. The light we see today is nearly 90% the age of the universe itself. Isn't that staggering? But there's a catch: the farther away a quasar is, the more redshifted its light becomes due to the expansion of the universe. This has revealed wondrous secrets about the nature of cosmic evolution and the growth of galaxies. However, the realm of quasars isn't just about their incredible brightness and distance. They also act as cosmic beacons that illuminate the mysterious cosmos we inhabit. You might be wondering how they do that. Well, the light and radiation emitted from these energetic objects serve as crucial tools for astronomers. By broadening their understanding of distant quasars, scientists can glean insights about the early universe, unraveling the evolutionary history of galaxies and black holes. This is like being handed a time machine, a way to access the early epochs of time and the formation of the cosmos as we know it today. Did you know that quasars were once believed to be stars? In fact, the name quasar reflects their initial identification as quasi-stellar radio sources. However, ongoing research definitively classified these objects as distant galaxies powered by supermassive black holes. This misconception is just one of the many twists in the quasar narrative, a reminder of our evolving understanding of the universe. Now, speaking of twists, let's unravel another layer of mystery. Quasars aren't static. They can show variability in brightness, sometimes dimming or even flaring up. Imagine a cosmic lighthouse that pulsates with the rhythm of creation. This variability can betray complexities in how the black hole is feeding on its material and in turn, how this influences the physics around it. The reason behind this variability could range from changes in the amount of material swirling into the black hole to gravitational interactions with nearby objects. You could even describe them as cosmic interviews, where each quasar has a distinct story to tell about their feeding patterns and environmental influences. If you're still with me, you might be eager to learn more about how we've managed to observe these dazzling phenomena. The technology behind quasar research has evolved tremendously. In the early days, astronomers utilized radio telescopes to detect the radio waves emitted by these celestial objects. Today, this has transformed with advancements in optical and infrared astronomy. Space telescopes allow us to study these objects in greater detail, unveiling their light curves, spectra, and physical characteristics with unprecedented precision. The journey of discovery has transformed from clunky radio dishes to dazzling satellite arrays that give us a front-row seat to the cosmic theater. Now, here's something you didn't expect: not all quasars behave the same way. Scientists have nestled them into two main categories: those that emit energy across all wavelengths, those are your classic quasars, and those that shine particularly bright in the X-ray spectrum, known as X-ray quasars. Isn't that intriguing? These distinct categories provide a fascinating insight into the diversity of black hole feeding mechanisms and the surrounding environments that dictate their luminosities. As we explore deeper, you'll start to realize that these powerful beacons have affected not just distant galaxies but also the fabric of the universe itself. Quasars emit intense radiation that can influence the gas and dust in their vicinity. They can even trigger star formation or quench it entirely in nearby galaxies, making them architects of cosmic evolution. In other words, quasars wield power not just in terms of raw light, they are fundamental players in shaping the very universe we inhabit. From a philosophical standpoint, you might start to ponder the role of observability in our search for knowledge. While quasars seem endless in their luminosity, they also remind us of the limitations of human perception. Imagine countless quasars flickering away in the dark, out of our detection range, offering narratives of their existence in a universe larger than we can fully grasp. Our understanding of quasars doesn't just reside in the dazzling details of their brilliance but extends into the realm of discovery. Each quasar is a place to decode the history of our universe, a clue to the enigmas we haven't yet fully solved. What comes next will undoubtedly leave you speechless, as we plunge headfirst into the implications of quasars and what they teach us about cosmology and deep space. For the curious minds among you, consider this: the universe was a dramatically different place when quasars dominated the cosmic stage. It wasn't just a collection of stars and galaxies, it was a realm where supermassive black holes were the engines of cosmic dawn, driving the narrative of creation. So, are quasars mere objects, or are they storytellers, portals to the past that beckon us to unmask the genesis of galaxies, stars, and ultimately, ourselves? As we peel back the layers of this cosmic onion, be ready for surprises that will challenge everything you thought you knew about our universe. In the second part, we'll decode how these brilliant celestial wonders can shape and influence their cosmic neighborhoods, impacting star formation and galaxy evolution on a grand scale. Stick around for that because, trust me, the revelations ahead could redefine how we perceive the very fabric of our existence. As we delve deeper into the world of quasars and their multifaceted roles in shaping the cosmos, we begin to recognize that their brilliance extends far beyond mere luminosity. They are dynamic forces that interact with their surroundings in profound ways. Quasars can be influential actors in the drama of cosmic evolution, impacting their host galaxies and the broader universe in several unexpected manners. One fascinating aspect of quasars is their capability to regulate star formation in nearby galaxies. Consider a scenario where a quasar is at the center of a galaxy surrounded by a cloud of gas and dust. The immense radiation emitted from the quasar can compress these clouds, triggering bursts of star formation. This phenomenon is akin to a celestial furnace igniting a spark within a cold, dark void. Stars, in their infancy, pull together the gas and dust in response to the quasar's energy, leading to the birth of numerous stellar systems. However, quasars can also extinguish star formation, acting as a cosmic double-edged sword. Imagine that same quasar blazing ferociously, its intense energy dissipating the surrounding gas and dust, preventing new stars from forming. Such quasar-driven feedback mechanisms can dramatically alter the evolutionary path of galaxies, steering them toward different destinies and, ultimately, shaping the universe's structure. This delicate balance underscores that what appears as light and energy can possess the power to create as well as to destroy. Further complicating this narrative is the realization that quasars come in various flavors, depending on their orientation relative to our line of sight. The unified scheme of active galactic nuclei suggests that the observed characteristics of quasars can depend heavily on the angle at which we observe them. For instance, some quasars appear more luminous due to our line of sight aligning with the jets of particles being ejected from the black hole's poles. Meanwhile, others may be obscured by dusty material, appearing less powerful. This means that, depending on our position, we might be observing the same underlying physical phenomena manifesting quite differently, like viewing the same scene through a fogged glass versus a polished window. Now, let's reflect on the broader implications of quasars in cosmology. As we utilize these incredible objects to better understand the universe, quasars lend themselves as markers tracing the evolution of cosmic structures. Because they are so luminous, quasars are visible even at vast distances, allowing astronomers to study the early universe. By observing the distribution of quasars throughout cosmic history, researchers gain valuable insights into how structures formed and evolved, making them key players in our quest to construct a coherent timeline of cosmic evolution. Using advanced techniques like spectroscopy, scientists can analyze the light from quasars, allowing them to determine the chemical composition of the gas surrounding them. This information reveals how elements were forged in the hearts of stars and subsequently propelled into space through supernova explosions. By piecing together the abundances of various chemical elements, researchers can deduce how well-understood processes govern the early universe's nucleosynthesis and how these processes influence the formation of future generations of stars and galaxies. Speaking of future generations, quasars help shine a light on the fate of galaxies. The interactions induced by these energetic giants play a role in determining whether a galaxy will continue to grow or dwindle through galactic winds or feedback loops. Star formation may flourish, leading to the creation of rich, vibrant galaxies, or it may decline, resulting in the lifeless shells of once bustling cosmic neighborhoods. This brings us to consider the broader question of cosmic evolution. How do phenomena like quasars weave into the tapestry of the universe, compelling galaxies to change and adapt through time? Moreover, quasars were more prevalent in the early universe, an era known as the quasar epoch. During this time, the number of quasars has been shown to decline significantly, leading scientists to ponder what this means for galactic evolution. The transition from a quasar-dominated cosmos to one in which we see our familiar, present-day galaxies reflects tectonic shifts in the universe's structure and energy distribution. This raises a captivating question. As you ponder quasar inflows and outflows, can these protectively intense luminous entities guard galaxies from catastrophic events? The interactions and feedback loops initiated by quasars can stabilize galaxies, moderating wild swings in star formation that would otherwise lead to chaotic evolutionary paths. In this sense, quasars may act as custodians of order in an otherwise chaotic cosmos, maintaining stability amidst the swirling energies of the universe. The technology that now allows us to observe quasars with such precision continues to push the boundaries of our knowledge. Instruments like the James Webb Space Telescope and other high-powered observatories have enabled us to examine these distant quasars in ways previously thought impossible. we can now peel back the layers of their accretion disks, zoning in on the complex arrangements and dynamics of materials spiraling into black holes. What's even more exhilarating is that we are actively discovering new kinds of quasars, including some that exhibit unexpected patterns of behavior. For instance, recent revelations have unveiled a class of quasars that seem to pulse consistently over time, suggesting a rhythm to their activity. Such discoveries prompt questions about the underlying mechanisms driving this variability. What kind of interactions or physical processes could underpin these pulsations? Are neighboring galaxies contributing to these oscillations? The answers remain tantalizingly elusive, fueling the excitement of ongoing research. But let's not forget, quasars are not just cosmic phenomena, they can also provide philosophical reflections on knowledge itself. Each quasar serves as a cosmic lighthouse, illuminating the vast expanse of our ignorance while simultaneously igniting our curiosity about existence. The journey to understand these titanic objects spans a multitude of disciplines, from physics and astronomy to philosophy and history. As we extend our gaze into the cosmos, quasars challenge us to confront profound questions. What does it mean to observe? To understand? To inhabit a universe so grand and intricate? As we approach the conclusion of our voyage into the quasar realm, it is vital to underscore that these phenomenal objects are more than immense light sources. They are cosmic monuments that give us glimpses into the past and act as signatures of the universe's evolving story. Quasars tether us to the early universe, serving as windows into epochs lost to time and narrating the energy ballet between black holes and galaxies. Reflecting on the journey we've taken, we have seen that the interconnectedness of objects like quasars plays a pivotal role in understanding how our universe works. They are not mere relics of the past or distant horrors embedded in the night sky. They are the DNA of the cosmos, weaving our reality together in an astonishingly intricate dance. So, where do we go from here? With each passing day and with advancements in technology, we are drawing closer to understanding how quasars influence the cosmos and vice versa. They invite us to explore further, to question more deeply, and to embrace the mysteries that still lie scattered across the starlit canvas of our universe. As you continue to gaze upward at those twinkling lights in the night sky, remember that each point of light carries within a narrative, one of creation, destruction, evolution, and endless inquiry. Quasars remind us of the beauty and complexity of the universe we inhabit, inspiring generations to seek answers in the void, forever embarking on a quest to decode the secrets that lie deep within the fabric of existence. So, remain curious, for as long as there are quasars shining in the night, the adventure of understanding the cosmos continues.